measure of it? Is it valid? So we always would ask, does that evidence exist supporting the claim that the scores on this instrument represent cultural competence? So all of these things you would want to examine and have good answers to before you claimed that, yes, teachers in Mexico seem to be more culturally competent than those in the US. So another question you probably need to ask yourself is also whether or not the scale is functioning the same way across groups. And that's a measurement and variance question. So it's yet one more thing you have to ask yourself before you get excited about your results. So when I think about measurement and variance, I'm asking, does the scale measure the same construct of the same metric across groups? So measurement and variance helps us answer this question. And it usually is done within a structural equation modeling framework, or a factor analytic framework is another way of thinking about it. It also could be within an item response theory framework. Okay? And basically, in the measurement and variance study, you're going to go through a series of steps. And you'll be evaluating the psychometric functioning of the instrument across groups in different ways at different steps. So to give you or before I go to that, why are we doing this again? Remember, what we want to do is look at those observed mean differences and say that they really represent true mean differences on this construct of cultural competence. And I wouldn't feel comfortable making the claim that the observed scores are good representations of differences in the construct without having first done a measurement and variance study. And I think Vanderberg and Lance have a nice quote here that kind of drives that point home. They say the unambiguous interpretation of observed mean differences is dependent on the between-group equivalence of the underlying measurement model. So we have to make sure that the underlying measurement model, again, the same construct is being measured in the same way, on the same metric across groups, before we can look at those two means and say that, yes, that does seem to reflect true group differences in the construct. So what are the different steps? How do we go about doing this? And this is just kind of giving you broad strokes of how you would go about doing this. I think that Debbie Vandelos and Jerusha Gerstner from JU gave a multiple-hour workshop on measurement and variance yesterday, so some of you might have attended that and know this pretty well by now. One of the first things that you do is you ask yourself, does the instrument have the same dimensionality in each of the two groups? So just as an example, it could be unidimensional in one group and multidimensional in the other. And of course, if you have different dimensionalities, if it's measuring different factors or different number of factors in the two different groups, then comparing the scores doesn't really make sense, does it? So that's like the first thing that you would do, okay? And you might be thinking to yourself, well, when would that happen? Well, one group might have a much more complex conceptualization of the construct that you're measuring than another group. Okay? And so that it could emerge in different dimensionality. And that's called step one, testing the configural invariance of the measure. The second step, if you're able to satisfy the first step and say, nope, we got the same dimensionality in both groups, then you can move forward and test what's called configural invariance. And basically what you're doing here, oh, sorry, this is the same step. I moved forward. Basically, this is another type of configural invariance problem. It's not that you have a different number of dimensions in the two groups. It's that you have the same number of dimensions, but items are loading on factors differently. So over here, items 1 through 3 are on factor 1, 4 through 6 on factor 2, but that's not what's going on over here. Okay, so actually, and this would be that the items have different discriminations across factors in an IRT framework. So that would not be good either. So the next thing that we would do, if we're able to find that, yes, the same number of dimensions are being measured in the two groups, and the items are matching the factors in the same way, then you would move on and you would ask yourself, okay, well, are some items more or less salient indicators of the factor of the two groups? Okay. And this would be, again, it might be that some items are more discriminating in one group versus the other. Okay. The factor loadings are different, or the item discriminations are different. That is testing the metric invariance of your scale. So if we have configural, we can move on to metric. If metric is satisfied, we move on to the third step, which is testing what is known as scalar invariance. And this is testing whether or not the intercepts are the same in the two groups. And basically, this would be testing in an IRT framework whether or not the item difficulties differ. Okay, but we don't usually say item difficulties when we're working with Likert scales. Okay. So if we're able to satisfy those first 3 steps of measurement and variance, then we can actually go on and compare the means of the two groups. Okay. So there are other steps that you could go through in measurement and variance studies that go beyond 3. But usually you have to satisfy at least those first 3 before you can move forward and say, okay, now we can actually compare the scores for the two groups. Okay. So all those 3 steps need to be satisfied. And one of the really great benefits of having people do measurement and variance studies is once you've done those 3 steps, and you're doing this all within a structural equation modeling framework, if you've satisfied them, if you pass them all, then now you have actually latent means that you can compare. So you have scores at the latent level for your two groups. And one thing that we like about that as measurement professionals is at the latent level, we're kind of free of measurement error. Okay, so we're able to make group comparisons on means that are free of measurement error, which is better than comparing the observed score means. Okay? So that's another kind of benefit. It's like, well, if you've gone through all this work to do the measurement and variance study within your SEM software program, then if you passed all the tests, then whoo, right there you've got your latent means. Take a look at them, see if they differ. So that can be a real benefit to the technique. So you might be thinking to yourself, well, why might we have, why might not we have measurement and variance? Well, like I said before, the conceptualization of the construct might differ across your two groups. It might be more complex in one versus the other. The clarity of the items, okay? So one group might be able to understand them pretty well, another group might have trouble understanding them. How the response scale is being used. This is an example that people give all the time. In some cultures, people use the entire span of the Likert scale when responding to items. In other cultures, it seems as being maybe a little too bold if you go to the extremes. So they will tend to use the middle of the scale more than anything and not go to the extremes. Well, that causes measurement variance, okay? So basically, another one, and I think that this is something that Lisa was tapping into, is you might be measuring another construct with some of the items, and that other construct your two groups differed on. That could be a big source of measurement variance or diff. So we have a lot of reasons why this might be happening, but the reason that we're doing this, remember, is because you want to compare the group means. Okay, so before you go forward and you do that, you really should do a measurement and variance study just to make sure that the instrument is being, or that the construct is being measured in the same way on the same metric for the two groups. So one of the nice things about being able to pass all the steps in your measurement and variance study, it helps you rule out plausible alternative explanations for your findings. Okay? So if you want to say, let's say we passed it with our cultural competence example, and then we can feel a little bit better about saying, you know what, I think that the teachers in Mexico do have higher cultural competence than those in the US. You can feel better about that because you've ruled out the possibility that a different construct is being measured in a different way in the two groups, and that the scale is operating differently in the two groups. You've ruled out those two plausible explanations for the findings. And the other great thing, now you get to look at things at the latent level, at the interview level. So, I think that's all I have.
Thank you so far to Dawn, to Lisa, and to Dina. Great presentations as always. And now back to me. So as I mentioned, this is going to be sort of a reflection on 8.5 years of working in ETS. There are many stories I could tell you. In the 10 or so minutes I have, I'm going to limit it to 3. These were 3 projects that I was very actively, or have been actively involved with. These are all acronyms, by the way, because at ETS we love our acronyms so much. So these all stand for something, and I will go through one at a time. And these are attempts. These are all sort of social mission-based projects in many ways, which is something that ETS takes great pride in. So the first one is the Consortium for Achievement in Mathematics and Science, or CAMS. And I had the pleasure of working on that with Dawn for several years.